Welcome to Unit 2 of Chem 203D Physical Chemistry 1. In Unit 2, we'll be looking at thermochemistry, and in our very first session, we'll be looking at why reactions occur. By the end of the session, you should be able to define some key concepts in thermochemistry, state the three types of energy, explain with examples the types of systems. Let's look at some terminologies. The universe. When we talk about the universe, we are simply talking about the universe composed of two parts, that is a system and its surrounding. So when we talk about the surrounding refers to the part of the universe in which the system is in contact, either directly or indirectly. When we talk about the system is a part of the universe of interest that we are actually studying. We have about three types of system. We have what we call the open system, closed system, and isolated system. When we talk about open system, in an open system, usually there is exchange of matter and energy with the surroundings. Example, when you have a beaker of coffee or a cup of coffee, you realize that your coffee cools down. Your coffee actually cools down because there is evaporation going on. So you are losing some amount of your coffee, and at the same time, the coffee is losing some energy. So usually in an open system, there is exchange of matter and energy with the surroundings. The same way when you take any open container containing any liquid, and depending on if the liquid can evaporate or sublime into the atmosphere. So basically, remember that when we talk about an open system leads to the exchange of matter and energy with the surroundings. When we talk about a closed system, in a closed system, there is no exchange of matter. However, there is always an exchange of energy with the surroundings. Example, when you have a flask of coffee or hot coffee, though you might not lose some components of your coffee, but your coffee cools down because there is an exchange of energy between the system and that of the surrounding. We can also talk about the last system, which we call the isolated system. And usually in the isolated system, there is no exchange of matter and energy with the surroundings. Example, when you have a thermoflask and then you store your hot tea inside, the hot tea neither gets cold nor reduced in quantity. However, note that we do not have what we call a perfect isolated system. Sometimes there might be some little amount of energy that is lost into the environment, or even if not into the environment, within the thermoflask itself, it absorbs some component of the energy. Now, when we talk about energy, what is energy? Energy is the capacity to supply heat or to do work. So we've all been hearing of energy. I'm drained of energy. I can't do this because I don't have energy. I need to take this energy drink. So what is that energy we are talking about? Energy is a capacity to supply heat or to do work. And that in mathematical terms, we define it as energy is equal to heat plus work. And we can classify energy either as kinetic or potential. When we talk about kinetic energy is the energy of a body in motion. That is, as the body moves, the energy it possesses is what we call the kinetic energy, or the energy that keeps the body in motion. The amount of kinetic energy in a moving body with mass m and velocity v is given by the expression half mass velocity squared. So if we want to calculate the amount of kinetic energy in a moving body, then we can simply do that if we know the mass of the body and the velocity, that is the speed at which the body is moving, we can calculate the kinetic energy. We can also talk about potential energy, and potential energy is a type of energy, or the energy referred to as stored energy. That is the energy a body possesses as it is not in motion. Perhaps energy stored in an object because of its position, or perhaps in a molecule because of its chemical bond. So when we are sitting, or as I'm talking to you sitting here, I have some potential energy. I don't have any kinetic energy because I'm not in motion. So the energy that is stored in me currently is what we call potential energy. Now, when we talk about energy, there is something we cannot talk without talking about: the law of conservation of energy, which actually states that energy cannot be created nor destroyed. It can only be converted from one form or state to another, which is important for you to notice because we cannot destroy energy. We can't even see energy. Energy just helps us to do the things we are doing, but we can't really say, okay, I've seen energy today, and or last night I saw energy, like the human being we see. But then, because of the energy, we are able to do so many things. But then, we can also find ways to quantify this energy. The mystery of this is we cannot destroy it. We cannot destroy and we cannot even create it. So it cannot be created nor destroyed. But then we can transform that energy from one form to the other. For instance, we can convert chemical energy into electrical energy using electrochemical cells. And the same way we can convert um, chemical energy into electrical energy. We can convert potential energy. We can convert energy from so many forms to another. All you need to understand is energy cannot be created nor destroyed. So the law of conservation of energy says that energy cannot be created nor destroyed. It can only be converted from one form or state to another. Now, as a session review, uh, try as much as possible to define the following terms in your own language as applied in thermochemistry: universe, system, surroundings, and state and explain the types of systems, state the law of conservation of matter, then distinguish between kinetic energy and potential energy. I hope to see you in the next session, and thank you.